Welcome back! Today we are going to take a look at Project 10 in the Arduino Project Book. This project is the Zoetrope. For this project we'll be using switches, 10 kilo resistors, a DC motor, H-bridge, a 9-volt battery, a battery snap, a potentiometer, and jumper wires. The kit came with some templates that we'll be using for this project. We'll also be utilizing the CD that we made from our pinwheel project previously. And I used a little box to kind of make a stabilizer for my motor. This will free up my hands, so I'll be able to use the potentiometer and the buttons. So we'll be using an H-bridge for this project, which is an integrated circuit. This makes it so we don't need multiple breadboards for our project and kind of conveniently puts everything in this one little piece. So you'll notice a little dimple on our IC circuit, and this is what marks the top of our circuit. So let's go ahead and start building our breadboard. So I already have the power and the ground hooked up to the power bus. Now I'm just going to add my potentiometer and my buttons and also my H-bridge. We'll connect the buttons, the potentiometer, and the H-bridge to the power. We'll also connect the two buttons to the digital pins 5 and 4. And then on our H-bridge, it's going to be connected to digital pins 3 and 2, and also number 9. I'll also connect everything to the ground. Our potentiometer is going to be hooked up to our analog pin 0, and we'll also be hooking up our motor and 9-volt battery to the power bus. The switches are going to be connected to the ground on that side, and as you can see in the potentiometer, I had to kind of move over, so I had to kind of put my connection to the analog on the other side as well. Next, I'm just constructing the Zoetrope to the CD that we made previously. I did have to kind of go get a butter knife so I could get my tabs in the right spot, but it hooks up pretty well. It's not a complete circle. It's kind of dented at one end, so that kind of throws it off a little bit, but it does work. So let's take a look at the code. So first we declare our constants for our output and input pins, and then we're going to create variables for remembering the program state. We also create variables for motor control, and then for the setup we just declare the digital pins as input and output pins, and we also turn the motor off. So for our loop, we're going to read the sensor information, which is going to tell us if our switch is on and off. It's also going to tell us like the direction, if it has changed at all. And we're also going to allow it to do the pulse width modulation for the motor if the motor is enabled. And then we also save all the current states for the next loop, so when it goes through, it'll know where it's at. So this code is a lot more complicated than the code we used for our pinwheel, but it also gives us a lot more control over the device. Like we can set the speed of the device, we can change the direction, and turn it on and off. And now it's time to upload the code to the device, and as you can see, I am getting some errors, and these are just minor errors of misspelling or forgetting letters, and I'll get those fixed up really quick. And here's our device in action. And here I'll slow down the video a little bit and show you through the slots of the device what it looks like. And there's our little LED guy kind of hopping up and down, as you can see. And that's the end of this project. So next week we'll be working on the crystal ball project, which is project 11 in the book. We'll be using an LCD screen in this project and creating a program to tell your future.